Good morning. This is a project about space architecture, space mining and space economy. I am Lucas Martin Dublanc. Here I attach a construction project designed for bases or habitats in outer space, which presents certain advantages over the current construction industry. This project has the advantage of being accessible in its construction by precast and press dressing methods that can be manufactured in a wide variety of materials, from adobe mud to concrete, and ceramic materials, etc. Where said blocks of mathematically solved construction, they do not need a joining mortar to join them together, making it a clean, neat, easy, simple and quick construction system to assemble in a short time and easy to operate without it being a dirty process, and not at all artisanal, optimizing serial production and efficiency thereof. I also have a prototype to show, designed to withstand extreme or hostile environments from the Lut Desert, where temperatures can range from 50 to 80 degrees Celsius to Antarctica, without exaggeration, to also be eco-sustainable and allow internal energy efficiency. Also, this hermetically sealed domed enclosure can serve to protect the astronauts at a controlled regulated temperature, as well as the internal atmospheric pressure of oxygen and nitrogen. It could also be understood as a large hyperbaric chamber, which is known has good effects on people's health. Also allows connections from electrical cables to rigid or flexible pipes or hoses, to carry inside hoses of liquids or gases just like water or gas pipes, as electrical cables for connections. Agri-space crops could be carried out in sealed and controlled environments, or have tanks for breathable gases, water, sewage, recycling and air filtration, etc. Also very easy to assemble the blocks without the need to use adhesives or mortars, high precision and anti-seismic blocks, thus keeping the vital supports intact in case of micrometeorites that break. One or a few blocks can be easily sealed and easily manufactured and repaired as it is modular. The mathematical construction blocks are manufactured in situ resource utilization, or IRSU. It is easy, fast, relatively economical way, easy to manufacture and easy to assemble in a short time. Also being hollow, they allow pipe connections. Rigid channels are flexible, water, gas, oxygen, recycled, and electrical cables and electronic systems. It is also a habitat resistant to earthquakes, as well as allowing it to function in various ways. Ideal for outer space, such as exploration and high hydrostatic pressures at the bottom of the ocean floor. It functions as a vaulted enclosure and bunker. It took me 7 years of research and development. The most important in this case would be the 3D CAED and STL files, since they are high-precision blocks, easy for mass production in outer space, with fiberglass molds, which are inexpensive and lightweight, thus reducing cost for transportation from Earth to space. It must be remembered that this new technology has many applications for industry and the international market, which can range from research and development of new medicines and drugs carried out in microgravity or in weightlessness, as well as in research into hydroponics and cultivation in space in adverse conditions for life, as a biological or biomolecular research laboratory, also as a research facility. Other fields could be in maritime, land and air defense as detection radars, in all directions without leaving blind spots, as in the telecommunications industry, also in all directions using antennas. Another application is for use in mining and underwater exploration in very high hydrostatic pressures, as being very simple. Could also be applied in private homes, or social housing in unpopulated places, or areas and in hostile conditions for life, etc. Now, in the rest of the video, what I explained before will be shown, but also at the end of the video, some renders and possible scenarios will be shown, where it is shown how different options of the habitat would look, both with all the tanks around it, with the recycling and filtering system of the breathable air, and it could also be water, but without windows. And there will also be renders in a version with hexagonal windows, harmoniously distributed around the habitat. Most likely they are made of a high-resistance translucent acrylic crystal, or PMMA, or it could also be a material called alum, or transparent aluminum oxynitride. As another possibility is that they were also hexagonal solar panels. Another of the renders will show a version of the habitat with larger windows. If you want to have more light, and see the outside in another way like on Earth, except that its production would be a little more complex than the small hexagonal windows, distributed in a geodesic way. The tanks would not only be spherical and interconnected by solenoid valves, but there would also be longer, cylindrical tanks, yellow, that could contain machines or systems for filtering water, liquids, air, carbon dioxide, etc., to then be reinserted inside the habitat, maintaining the quality of life of astronauts or internal users as best as possible. They could also be used in hot deserts for nomads on Earth, and function as rest and cultivation stops in extreme environments for humans. Hermetically sealed or not, and could be large hyperbaric chambers with controlled environments inside, both in terms of atmosphere, climate, air quality, pressure and internal temperature control of the enclosure or habitat. The building blocks can be made from materials such as adobe clay or concrete, ceramic materials or clay, recycled plastic materials or polymers, or even lunar or Martian soil regolith inside fiberglass molds created through a pre-molding process. In outer space it would not need water, since the lunar regolith could be hardened inside the molds with tanks of carbon dioxide CO2 gas, hardening it with a stream of CO2 gas, injecting it into its interior, forming an agglomerating gel of the material or internal regolith, just as it is done with synthetic sand in foundry, as it is done in the manufacturing processes of the foundry cores that are broken for aluminum casting molds and generate the internal hollow parts. For example, once they harden and the blocks are assembled in the enclosure, a cement mortar spray gun can be used for large surfaces to be covered. The material that could be used here could be a material like it, Line X material, which is a protective coatings, which serves precisely to protect the blocks, both externally and internally, from impacts, and would also help to seal small empty spaces, perhaps produced by small erosions or friction between the materials of the blocks to be assembled, and where atmospheric pressure or internal oxygen gas could escape from the enclosure to the outside or high vacuum of space. Thank you very much for your attention to my project. Best regards, Lucas Martin Dublanc. Good morning. This is a project about space architecture, space mining,